So in this presentation, what we're going to take a look at is how we can go ahead and solve radical inequalities. And what we're going to see in this case is the fact that we're going to have a radical on one side of the equation for us, or I'm sorry, radical on one side of the inequality symbol. And so the difference is going to be, instead of just having one answer, we're going to have a solution set. So if we take a look here, and if I want to go ahead and start this problem, I'm going to solve it envisioning that it's the same as an equal sign. And so my first step here is just going to be to go ahead and take and square both sides, and I get x minus 3 is equal to 4. And then that's going to result in the fact that x is equal to 7. So 7 ends up being that critical value there for me. And another aspect I can actually go through here is by thinking about, what does this actually even look like? And so if I take a look at this equation as a graph, I would see that it would be similar to us saying the square root of x minus 3 minus 2 is greater than or equal to 0. So going back to our mindset of quadratic inequalities, I could think about the graph a little bit. And with the graph, I could anticipate that the graph would look like the following. It would have a right shift of 3, a down shift of 2, and it's going to look something like so. And so from here, I think we can envision then that what we just found was this intersection point, which is actually occurring at 7, or when the x value is equal to 7, I should say. And so furthermore, what I see is that our inequality would be y is actually less than the radical. I know that's a little bit unique in that case, but it's y less than, which actually means we're going to be shading into here, which then tells me then that my statement, or my original equation, would be such that the solution set begins at 7 and goes the whole way to infinity. If I didn't want to use the graph like I did here, what I could do then is I could actually substitute in values. If I'm saying my critical value is at 7, I could then go ahead and pick the value of something that's bigger than 7 and substitute it into my equation. So let's just say, for lack of better words, we go ahead and we substitute an 8 into the equation. So if I substitute an 8 in for x, I know that 8 minus 3 is going to result in 5. And so now the left side of my equation becomes square root of 5. And I have to think, is the square root of 5 greater than or equal to negative 2? And that is true. So that is telling me then that, again, all my values bigger than 7 are going to satisfy this statement. Now, in the second example, we're going to see that possibly, there's an alternative here. So let's take a look at the second example. And in working on the second example, I'm going to start off by, again, just simplifying and solving this as if it were a regular equation. So I'm going to subtract 3 to both sides. And upon subtracting 3, that gives me 3x minus 6 is less than or equal to 3. I square both sides. It gives me 3x minus 6 is less than or equal to 9. Now I have a nice basic linear, which is going to be 3x is less than or equal to 15. And again, just moving through the actual problem there, I can end up getting x is less than or equal to 5. Now, something interesting happens in this case, especially since one of the look-fors here is that I have a less than or equal to. Because intuitively at first, I'm thinking that my answers will go from negative infinity to 5. And I used the wrong inequality symbol there. So I actually want to erase this. So we can't be equal to infinity. So actually what I'm going to do is just go ahead and take the whole thing off there. There we go. And then from here, we would actually go from, again, sorry about that, negative infinity to 5, like so. But there's something unique about this, and I have to be careful anytime that I'm going from negative infinity to a value. And that's because that's incorporating all the negative values, and that's something that's a little bit of a red flag, especially since I have a square root. So I have to kind of cross-reference now what actually is taking place with what I calculated, as well as what's taking place in the original equation. And what I mean by that is, let's just go right to here, and I got to think about what the domain is for this original statement. And from the square root of x, square root of 3x minus 6. So if I'm thinking about this, square root of 3x minus 6, I know that my domain for that problem is such that the x values have to go from 2 to infinity. Anything less than 2 is going to give me a negative number underneath the square root. And so therefore, this is my domain for this portion of the original inequality. So if I actually cross-reference then the two statements here and here, this is telling me that my solution set then must go from 2 to 5. And I can be equal to those. And that should confirm in there, because if we go back and look at our equation, if I substitute a 2 in for x, by substituting a 2 here, we can end up seeing that, we get a value that 3 times 2 is 6. 6 minus 6 is 0. That would result in just a 4, and 4 is less than or equal to 7. So that's good. If we go the whole way up and put a 5 in, that gives us our whole 15 minus 6, which is 9. Square root of 9 is 3. 3 plus 4 is 7. So that's good. But anything outside of that realm, all of a sudden, is going to give us either an illegal value upon substituting it into our original statement, or something that doesn't satisfy the inequality. So those are a couple things to check for. And then finally, we have our third example. But in our third example, we're going to use this as a preview item. So that way you could go ahead and kind of revisit the first two examples. And then before attempting to view the next instructional video, make your own hypothesis on what you think the solution set would be for number 3.